Hello everyone, we're solving another hard problem. Turns out I solved that one, but I didn't even remember that until I clicked on the link. And I didn't see the solution, so it's almost as if I'm starting from scratch. But I still have an idea just from the name of it, maximum points on a line. I pretty much am sure about what will this be. Okay, so signature will be points, and it will be lists of integers. And essentially, each of those lists is just two integers, two for coordinates of a point, but it's fine. And we are returning maximum number of points. So maximum number of points will be an integer. Let's now think about tests a little bit. So let's start with the corner keys. So if there are no points, we will be returning 0. Now let's say that we have just points 1, 2, 3, 4, and 5, 5. So here we will have 2 points, and it can be any 2 of these points. I'm thinking about the solution. I have a hunch. Let me just share this hunch right away. So it's dx by dy is my hunch, which is for any points that lie on a line, we will have at least the same ratio for between delta x and delta y for those 2 points. Okay. I don't know yet how to operationalize this. One of the problems is that, let's say we have a test something like 1, 2, 3, 4, and 5, 6. And let's also say that we have 2, 3, and 4, 6, right? So the thing is that these 3 points are on the same line. Oh, are they though? So it's +2 +1 +2 +1. No. Okay, I probably need to draw something. So let's say there is the point here, and then there is a point here, and then there is also a point here. So these 3 points are on the line, but let's say that just below them there will be also 2 points on the line. So here the answer will be here I was thinking about delta, so it will be 4 minus 2 is the delta, and 3 minus 1 is the delta, so it's 2, 2, and 6 and 5, yes, so deltas are the same here, and also the same here. So this is what I'm more or less trying to draw here. And the problem is that they will have the same deltas, but they are not lying on the same line. So we also should have to choose some point, and calculate, starting at this point, what are the deltas for all the points. The problem is that if we choose a specific point and calculate deltas to this point, if we choose this one, yes, we will be able to find how many, like all of those points will be on the same line with this one. So that's fine. But what if we choose this point? And if we calculate deltas from this point to all the other points, then we won't find these three that all lie on the same line. What other ideas do I have? Another thing that I'm just thinking about is that even if we have many deltas that are the same, many slopes that are the same, it doesn't mean that points with these slopes will be lying on the same line, because it can be three lines like this on different heights, right? So something like this, for example. But all of those points are not lying on the same line. So let's say we also have this, right? Okay, we still have 3 points. Maybe let's also have this, right? So there will be more points lying on the lines like this, going to the upper right, but there will be essentially 1, 2, 3, 4, 5, 6. Yeah, so 7 points like this, but these 4 points will be lying on the same line. So we should be finding this direction as the main one. So one of the things that I'm thinking about is that there are at least 2 such points. So for any 2 points, there is line going through those 2 points. So if we just find the slopes for all the pairs of the points, one of those lines will be guaranteed to be the line. So by iterating over all possible lines, we can get to the line that is the correct one. But then we need to figure out if it's the correct one. I'm thinking about some non-elegant solution right now. But let's say it's kind of a brute force, but optimized brute force. So first we find all lines. Thus we'll find all slopes. and then pointer, okay, basically a dictionary that will be slope and 2 points. No, slope and all points. So what I was thinking right now is how do we normalize the slopes? So the slope can be normalized as 1, which is the, let's say, default delta x, and delta y divided by delta x. So we can normalize and just keep delta y this way. But then there will also be the slope that has 0 here. So there will be delta x of 0 and then some delta y. And this one we cannot normalize like this. So I guess we will just create a separate dictionary for that. Say this will be our pointer. So there will be like integers, and here it will be a tuple as a separate separate pointer. So this way we can normalize all the slopes, and for these slopes find the pair of points that lie on this slope. Actually, here is another idea, because here we cannot point to points. We will be pointing to pairs of points, creating this slope. What if instead we wanted to store this as a combination of slope and a point on one of the coordinates plus slope, and then points on it. So let's say that we want to find for any point, for any 2 points, for any pair of points, what is the point on x coordinate axis where this particular line will be crossing, and then any points that lie on the same line will also be mapping to the same line. And then we will be able to find, because a combination of the slope and a point on the coordinate axis will be everything that we need to know. Or to identify a specific line uniquely. Yes. So then, what do we need to do? We need to do first, we need to iterate find all lines, all slopes, and then, yes, we need to do point on coordinate plus slope points on it. So this will be basically of n squared operation. Let's say there will be of n points and points. So of n squared. For that, then second, find the maximum. Oh, another corner case that I didn't think about that is probably important. can we have duplicate points? Can it be something like 1, 1, 1, 1, 1, 2? Where are the maximum points on the straight line? Yeah, this becomes trickier because 1, 1 and 1, 1 don't lie on any specific line. So let's check if all points are unique. Good, that's good to know. It's possible to also process this kind of corner keys, but it's less straightforward. We would basically need to calculate not just the point, like the number of points at these coordinates, and then treat it as a separate parameter for each point. But otherwise, it won't change things much, the overall algorithm among the lines. Okay, then here it will be of there is at most n squared possible lines. So finding the length will be of n squared. Finding the max there will be of 1. Yeah, finding the value of the length, the number of points lying on this line will be of 1. And for each line, we will find the number of points, and then we just return the maximum number. So it will be of n squared in total operations, which is good. So I think it's the fastest that we can be. Yeah, I don't know if there is a faster approach. I cannot think if it's even possible. So let's implement this now. For x1, x2 in points. Oh, actually, we just need to iterate for I in range. We don't want to calculate the same points twice, so we will do it in cycles that are just doing each point combination once. So let's say that n is equal to length of points, and for I in range n, but it will be not range n, it will be n minus 1. And for j in range I plus 1 n. So these are all the possible pairs of points. x1, x2 will be points I. Okay, I think it will be better. x1, y1, x2, y2 is points j. Okay, now we will either have, we don't know, okay, so let's say, yeah, I think we need to do this. So dx will be, dx dy will be x2 minus x1 and y2 minus y1. Then we also need to figure out how to calculate the point where they're crossing. Okay, 20 minutes have passed. I'm restarting the timer. So how to figure out the point where the line is crossing x coordinate. So we need to take any of the points. We need to take the slope. This will be the third line that is lying on the same line. So let me solve it here. So, okay, so there is like one line which is x will be x, some x, and let's call x 0 and y will be 0. Then this point, so x plus dx times k will be equal to, let's say, y1 plus dy times k. So here we need to calculate this x zero and how do I calculate this? I can do x0 equals y1 plus dy. Yeah, there are two. I'm trying to figure this out. It was a long time since school math, so I basically am figuring this out from scratch. So no, this will be minus, but I'm not thinking about this plus dy times k. The problem here is that we have two unknowns, right? One of those is this, and another one of those is this. So the problem is that we cannot learn it just from that. We will also need to do no. Okay, I think this is also incorrect. So what we need is like x1 will be x0 plus dx times k, and y1 will be 0, which is y0 plus dy times k. So from this, we know that y1 will be equal to dy times k, and k will be equal y1 divided by dy, and then x0 will be x1 minus dx times k, which will be x0 will be equal to x1 minus dx times y1 divided by dy. Okay. So now we have found our point. What's the problem? The problem is when dy is equal to 0, which is fine. We can figure this out. This will be a separate thing. This will, if dy is equal to 0, we will have a simplified solution for this. So, okay, now, one last thing that we need to figure out is that dx and dy can be either both positive or both negative when we consider points like this too, or they can be, one of those can be positive, another can be negative when we consider points like these two. So to standardize this, we basically need to divide by dx and divide both by dx. So here we are assuming I'm just trying to think. Here we want to divide by dx, and here we will want to divide by dy. So let's say that we have two combinations. If dx is equal to 0, then what does it mean for us? It means that it's a vertical line. Then we will be creating this dictionary. Okay, so slopes will be dictionary. I think we need to add default dict. Of set, because we will basically be adding each line twice, each point twice, because we will be considering many combinations of lines. So not twice, n squared times. So we don't want to add one point many times because all points are unique. Yep. Now we need to define the slope. So I wanted to define the slope this way, but let me define it differently. Let me define the slope in a little bit more clever way, which is dx, dy, and x0, y0. So then we have three possible combinations. So it will be, if dx is non-zero, then it will be this, dy divided by dx, x0, y0. So then our slope will always be just one number because we are dividing those two values. And then x0 and y0, y0 will be, since here we will always be finding x, so here we have that. Now there is another possibility, which is if dx and dy don't equal to 0. If dx equals 0, then what will our slope be? We still have our x0. If dx is equal to 0, then we have a vertical line, so we will be x0 and 0 here. But these things stop being reasonable, so it will be this slope. And else, if dy is equal to 0, then we will be defining slope as infinity 1, and there will be 0 as x and y0 as a point. So now we can finally do that. If dx is equal to 0, then slope is equal to 1 float of infinity x1 and 0. Actually, slope is a bad name. It's not slope, it's lines, and this is line. Else, if dy is equal to 0, then line will be this 0, y1, else we have dx dy will be equal to dx divided by dx and dy divided by dx. And then we will have x0 will be equal to what we have calculated, x1 minus dx times y1 divided by dy. And then the line will be equal, so dx dy, and then x0, 0. Finally, we have figured the lines, the slope, the line. So now we can add it to the lines. The lines of the line add x1, y1, and lines of line add x2, y2, and then turn max length of points for points in lines values. Well, this looks like it. Let's see if something like this works. So let's calculate this here. But I think I also need to do something like, instead of 2, 3, 4, 6, let me also add 2, 2. Okay, so n equals to length points, which will be 6 in this scenario, 6 squared. 36 points we will have to consider, but we won't be considering all of those. We just need to consider some corner cases. But we will need to also store pointers. So let's say we have a pointer to a specific point. So this will be I, this will be J, and it's pointing not just to one, but to the whole tuple, whole list. So the first will be 1, 2. The second will be 3, 4. So delta x, delta y will be 2, 3 minus 1, 2, 4 minus 2, 2, 2 and 2. And they are not zeros, so it will be the slope of dx divided by dx, which is 2 divided by 2, 1. So 1, 1 is our slope. And then our line will be, the first line will be one, then x0 will be what? x1, which is 1, minus dx, which is 1, times y1, which is 2, divided by dy, which is 1. So 1 minus 2 will be equal to 1. Oh, minus 1, sorry. So minus 1. And let's check. So this point, x1, y2, yes. It should be minus 1, 0 should lie in this point. So this is correct, minus 1, 0. This will be the line, which is nice. This is correct. Let's also consider that, let's say we got this point before this one. So our deltas would be minus 4 and minus 4 again. Oh, I see messages. Let me check actually. So there are chat messages. Nice to meet you, bro. Would you like to guide me? I would like to guide myself, to be honest. I need to solve this problem and drop off quickly. Okay, so here are all those points. Yeah, let's say we are considering those points, but we were getting -4 and -4. And here we would be getting dx by dx, which is again 1, and dy by dx, which is also 1. So this is correct, and the slope will be this one, and then we will, it lies on the same line, so we will be calculating the same x0. And now for this, we will have a pointer. Let's just put it here. So default dict of set, so it will be this line now points to a set of points, which is first 1, 2, and second 3, 4, and third it points to 5, 6. And then for these two, for example, let's say 2, 3, and 2, 2. Yeah, this one will create a different slope because we will have different x0. It will be -2 and not -1. And for these two, we will see that delta y is 1, but delta x is 0. So if delta x is 0, then line is 1, float infinity, x1, x doesn't change. It will be always 2. So it will be 2 and 0. Yeah, and that is correct. Okay, looks reasonable. And as if we have processed the corner cases. Let me just check one final thing, that all the tests are actually passing. So this should be returning 0. I think it will be returning 0. But just to be sure, let's say if n is equal to 0, return 0. And I haven't processed this corner case, and other corner cases haven't thought about that. Let's say that there is just 1 point, then there will be an answer of 1. N equals to 1, return 1. Which, yes, in our scenario, this would have been broken. Now we have everything correct, at least according to our tests and checks. Points. Okay, submitting. Nice, fast solution. Maybe not the fastest, so there are probably better ways to calculate some of the intermediate stuff, but at least it works. And let me just change it here and close the room. So yeah, let me now read another message. I want to learn system design. Actually, Savage Bridgesh 12. I will be also teaching system design. I am preparing a course on this right now. I haven't announced that, but I'm using the Feynman method to learn it, basically to understand material myself and then to teach it to others. So keep track of the channel. I will try to post a message on the channel when I will be streaming this course. But yeah, you can expect that. Today we obviously didn't do much of machine learning system design. It's mostly just LeetCode problems that I'm solving, but it's still part of the whole thing. So that's what I'm doing. Okay, thanks everyone. And yeah, I'll see you tomorrow, I guess. Bye.